Hey everyone, welcome back. Today we are looking at a really interesting problem from the ISI admission test, which if you don't know is one of the toughest entrance exams in India. So what is ISI? It stands for the Indian Statistical Institute. It is a world famous institute known for producing some of the sharpest minds in mathematics, statistics and computer science. And trust me, their entrance test is no joke. Some people even say it is tougher than JEE because here it is not about grinding formulas, it is about pure problem solving and mathematical creativity. Every question feels like a little puzzle, short, elegant, but surprisingly tricky. In this video, I'll take you through one such ISI questions which is relevant for your JEE step by step and show you not just the solution but also the thought process behind it. So let's jump right in. I'm Abhinav. I've done both my bachelor's and master's in electrical engineering from IIT Kharagpur. So what do we have here? So you are given a container and the shape of the container is obtained by revolving a segment of a parabola x is equal to y square. So you have this particular segment of a parabola x is equals to y square and you're going to revolve this segment of a parabola about y-axis, and the segment considered is from y is equals to -1. So if you see, this is x is equal to 2. When you put x is equal to 2 here, you will get y is equals to plus or minus 1. So the height of your container is 2. The height goes from y is equals to -1 to y is equals to plus 1. So that is the segment of the parabola that you are revolving about y-axis, and you are obtaining this particular shape for your container. Initially the container is empty. Okay, so the trick to solving any geometry problem, any coordinate geometry problem, for instance, is to make a good figure out of the information given in the question, and make sure you read each point clearly, religiously, and note down the information in mathematical terms. So let's do that. So you have the equation x is equals to 1 plus y square. So the radius at the top and bottom is given, that is x is equal to 2 centimeters. So your y varies from -1 to +1. So this is the initial information that we got from the first point. So let us go to the second point. The container is initially empty. Water is poured at a constant rate of 1 centimeter cube per second into the container. So there is no water at the start, which means at t is equals to 0, volume of water in the container is 0, and water is poured at a constant rate of 1 centimeter cube per second. So that means dV by dt is 1 centimeter cube per second. Let ht be the height of water inside the container at time t. So at t, h of t is the height of water in the container. So what do we have to find out? Find the time t when the rate of change of ht is maximum. When dh of t upon dt is maximum, what is the value of t? So this is what we have to figure out. Alright, this is given, dv by dt is given. So let us find out the volume of water in terms of h of t. Alright, so to do that, I have considered, so this blue thing is your water and you have a disk here. So dh is the thickness of the disk and h is the height of water. When h is equals to 0, so your water will be till this portion, till your x-axis. When h is equal to -1, it is empty, and when h is equals to 1, the container is full. Alright, so your height varies from -1 to +1, this thing. Alright, so now to find out the volume of water, let us say you have water till some level, this particular level, this level. So to find out the volume of water, I have considered a disk which has a thickness dh and the height from the x-axis is h. Alright, so now this disk is simply a cylinder. So what is the volume of the cylinder? Volume of the cylinder is simply pi r square h. Alright, pi r square h. I am finding the volume of this particular disk. What is the radius r? Radius r at this point is simply the x coordinate. Alright, x coordinate at this particular point. So pi x coordinate is 1 plus h square. So since this height is h, from this particular equation we get x coordinate as 1 plus h square whole square multiplied by the thickness of the disk. This h is the height of the cylinder. Alright, so the cylinder that we have here is the disk. So we have to consider the height of the disk, which is dh. Height of the disk is nothing but thickness of the disk. Now this we have to take one disk here and then another disk here, another disk here, and we have to keep going up like that and add up all the volumes of such disks to get the volume of the container. So your h varies from -1 to h, any particular height h. When your h is 0, your container will be filled till this portion and you'll get the volume of this particular portion. Alright, when your h is 1, your container will be completely filled with water and you will get the total volume of the container. Alright, for an arbitrary height h, the expression for volume v of h is this particular thing. So now let us perform integration and find out what v of h is. So v of h is simply -1 to h pi 1 plus h square whole square is simply 1 plus h power 4 plus 2h square dh. So if you integrate this, you will get pi times of h plus h to the power 5 upon 5 plus 2h cube by 3, and this varies from -1 to h. So pi times, when you put h, the expression will not change, h power 5 upon 5 plus 2h cube upon 3. When you put -1, you will get plus 1 upon 5 plus 2 upon 3. Alright, so this is simply pi times h plus h power 5 upon 5 plus 2h cube upon 3 plus 28 upon 15. Alright, v of h. So if you want to check whether the expression you have here is correct or not, you can put some values into this expression and check. When h is equal to -1, so h is equal to -1 is this, your volume should be 0. If you calculate, if you put h is equal to -1, you'll get 0. When h is equal to 0, when h is equal to 0, your volume, your container is half filled. It will be till, the water will be till this particular point. When h is equal to 0, you'll get 28 pi upon 15 and v of 1. When h is equal to 1, your volume will be, your container will be completely filled. And when you put h is equal to 1, you will get 56 pi upon 15. So your v of 1 is just the double of v of 0. So this should give you a conviction that whatever expression you have calculated is correct for the volume of the container in terms of height h. Alright, so it is a good practice to put some values whenever you calculate any expression for any quantity and check. So this is called as corner case checking. Actually, you know the values for some corner cases and you check for those values. Alright, so now we got dv by, sorry, v in terms of h. So now the only information given in the question is this thing, dv by dt is equals to 1. So dv upon dt is equal to 1. So differentiate this particular expression with respect to t on both sides. Alright, then you will get dv upon dt is equal to pi times differentiation of h is 1 and you have to differentiate h with respect to t. So it is dh by dt plus differentiation of h power 5 is 5h power 4 upon 5 multiplied by dh by dt plus h square multiplied by dh by dt, and differentiation of this particular quantity is simply 0. So your dv upon dt is simply pi times 1 plus h power 4, so this is actually 2h square, plus 2h square multiplied by dh by dt. Alright, so this is simply pi times 1 plus h square whole square dh upon dt. So this is your dv upon dt, and dv upon dt is 1. It is given in the question. So dh upon dt is equals to 1 upon pi times 1 plus h square whole square. Alright, now we have to find the value of t when dh upon dt is maximum. So dh upon dt has to be maximum. So this particular quantity has to be minimum. And since it is a perfect square in the denominator, this will be minimum only when h is equal to 0. Therefore, dh upon dt is maximum when h is equal to 0. But we have to find the value of t at this point. So again, consider dv upon dt is equal to 1, which is given in the question. Dv upon dt is equal to 1. So dv will be simply dt. Alright, if you integrate this on both sides, you will get v is equal to t plus some arbitrary constant c. But when t is equals to 0, volume is equal to 0. So this implies c is equal to 0. Therefore, volume is simply is equals to time. Alright, in this case. So dh by dt is maximum at h is equal to 0. So at h is equal to 0, if we find the volume, we will know the time as well. Alright, since volume and time are same. So let us find the volume at h is equal to 0. So here we have the expression for volume. So at h is equal to 0, volume is simply 28 pi upon 15. So since v is equal to t, so t is equals to the volume at h is equal to 0. So 28 pi upon 15. So this is the time at which dh upon dt is maximum. Alright. So this is a very nice problem, very beautiful problem. So you have to imagine a lot of things. So the practice of considering a disk and realizing that the considered disk is a cylinder and putting together so many such disks one above the other and integrating to get the volume of the container is such a common practice in physics. So you do this all the time while solving your mechanics problems. So we have adopted the same technique here, and this is the very definition of integration. So we have adopted the same technique here and calculated the volume and the other things which are asked in the question. So if you have any queries about this question, do comment them down. I'll get back to you. And if you like the content that I'm making, leave a like, share it with your friends, and subscribe for more such content. And I have some fantastic videos for you on the end screens, and do feel free to check them out. Let's meet in the next video.